Why am I playing this song? Because I got my stylist back. It's working. Harmon Stylist is back. All right. This is spring break like 1998. All right. All right. Time for me to start acting like a professor, I guess. I'm so excited, you guys. I emailed them. They sent me an update for my stylist, a software update. I'm happy. Okay. Let's continue on. So let's get into it. Valence bond theory, or VB theory. It is a theory rooted in quantum mechanics. So basically that means the orbitals. And it incorporates the assumption that covalent bonds formed when half-filled orbitals on different atoms. So half-filled orbitals on different atoms overlap or occur in the same region of space. Okay, so what that overlap means, right? So it's a term used in valence bond theory that describes that how bonds, chemical bonds, can arise when two atoms are literally overlapping in the same region of space. Okay? So for example, in this hydrogen, so if I have two hydrogens, right, and they're two half-filled orbitals, one s1 and one s1, okay? So as I move them closer and closer together, so when I move these two hydrogens, right, these are both, you know, 1s1 hydrogens, both half-filled orbitals, right? And as they move closer and closer together, as they overlap, they form a bond, a single bond. We call that a sigma bond. Sigma, Greek letter for S, because it's really made from two s orbitals. So we can think of that as a single bond. I got my stylus back, but my handwriting still hasn't improved. So I want to show you a really cool simulation that I have on a program called Mathematica. We do this in my Chem 362 class, which is quantum mechanics for chemistry majors. If you are a chemistry major, you will have me eventually in physical chemistry, Chem 361, Chem 362. So this is a very cool program, all kinds of nasty math that you don't have to know. But what's really cool about this program, we've simulated two hydrogen atoms, and I can move them closer together. So this R2.5, that's 2.5 angstrom, which is 2.5 times 10 to the minus 10 meters apart. And what I can do in this really cool program is I can move them closer and closer together. And so you can see there's still two, like, you know, 1s hydrogens, 1s1, and I'm getting them a little bit closer and closer, and it takes a minute to update. And now what maybe you can start to see is the shape is starting to get elongated. So the nuclei are becoming attracted to the electrons in the opposite molecules, okay? And so if I move them close enough, you can see that now they're starting to share overlap, and the hydrogen-hydrogen bond is observed to be about 1 angstrom. So there we go. Now I've, you know, on my computer made the H2 molecule with shared electron overlap that creates the sigma bond. Okay, so each of those dots represents each hydrogen nuclei. And all of this stuff around there, that's what we often refer to as the electron density. So this really would be kind of like what the molecule would look like if we could see it, at least we think, based on this idea of overlap, okay? So we call this process hybridization. So that's another term in valence bond theory, where this is the mixing or the overlap of atomic orbitals to generate, this should say a new set of orbitals that can then form covalent bonds. Okay? So let's go through that.